Well, we find ourselves at section 18.4 on polymer chemistry. I had at least one concerned student say 18.4, isn't 18.5 the last chapter in the book? And it is. Well, what are we going to do? We're just going to take the whole rest of the time off? Sorry, I know some of you might be interested in doing so, but there is 2 chapters we skipped. We're going to go back to those. So we're actually going to be like YouTube Rewind here and take a look at what we missed. They're not my favorite chapters in the world, but they do dive into some random stuff in chemistry, particularly the usage of common nonmetals in everyday life. As does this chapter in chemistry. It talks about usages of carbon and its affiliates in modern life. So let's go through this. It's actually a super short section, so we're just going to plow right through. Polymers and monomers. Of course, you have hydrocarbons. Some are small, some are super large. Polymers are made of many different hydrocarbons linked together, and polymers are formed by monomers through the process of polymerization, chemical process which puts monomers into long strings and makes them into polymers. And here's an example of polymerization. You have ethene here, and you shove them all together and you get this super long continuing on hydrocarbon. And these long hydrocarbons have some pretty unique usage. We're going to look at that in just a second. Here's some common polymers, large strings of hydrocarbons. Vinyl polymers like PVC, piping, or like a vinyl wrap on a car. I never really liked the whole wrap on a car, but anyway, these are vinyl polymers. Polyesters are polymers made up of many esters. These are used in many clothing fibers. Balloons are made of polyesters, so if you ever had a birthday balloon, these are a common polymer. It's not like it's natural. It's not like you can go out and find what they make birthday balloons out of in, your backyard. It's not natural stuff. You do have to make it through polymerization. Soda bottles, same thing. Most of them aren't being made out of glass anymore. You do have some sort of polyester. Polyamides. These groups are known for nylons, cables, etc. So there are some pretty good uses of polymers. Some less common ones, polycarbonates, are made into shatterproof windows. We do not use glass windows. Glass actually we found to be less useful because glass is not a perfect solid. Glass over time actually kind of melts, and it is more amorphous in composition, so we use a polycarbonate for all your windows. Polyurethanes, adhesives, furniture, elastic clothing. Polymers had influence on biology as well. Some proteins are made of polymers that your body puts together. Glucose is C6H12O6. It's a large molecule. Well, it's actually derived from a couple of different things. Water and oxygen, carbon dioxide, all put together into making it into glucose. Chitin, and that's something that is in plants. DNA, deoxyribonucleic acid, long strands of polymers. Cellulose, these are all polymers. And kind of a final remaining idea, a silicon world, take a look at the periodic table. I'm going to pull one up. There you go. So here's the periodic table. You can see that carbon has 1, 2, 3, 4 bonds away from being a filled octet rule following atom. So does silicon. So does germanium, tin, lead, etc. But particularly the ones that are towards the upper part of the periodic table are the more useful ones, the ones that bond a little bit more. So let's talk about silicon. A silicon world. Now, carbon is pretty pervasive in our world. It's everywhere. But what if the world was made of silicon? What if every carbon we substituted, instead of like a hydrocarbon, we had a silicocarbon? Well, it turns out that silicon does the exact same thing as carbon. We can make things that are hydrocarbons into placing silicon in where all these carbons are and see what it does. And we found that it does something similar, but a lot of the time it changes what it does and actually makes it more useful. So for instance, where we might have something like, let's say, pentane. We substitute silicon in for carbon, and now we have a sealant. And so pretty much every caulk, like a roofing caulk, I used caulk all the time, which seals stuff, or like a sealant that you might put around your tub to prevent a leak, even surgical equipment. All these are made out of silicon, and it took us until we found out, hey, maybe let's substitute carbon for silicon before we actually realized the benefits of doing so. And so we're experimenting even today on making new tough rubbery sealants, and silicon tends to make things a little bit thicker than carbon because it's just a bigger molecule, and thus it has different effects. Well, anyway, you have a section review to do. I'll leave you to that, and we'll do some biochemistry on Monday, and I hope you have a great weekend. I'll see you.